Hello, this is the section 8.1 lesson. In chapter 8 we're going to change gears a little bit and not talk so much about the how and why we do arithmetic the way we do it. We're going to talk about some properties of numbers. And these properties we're going to talk about fit into the general category of math that we call number theory. In section 8.1 we're going to introduce two important ideas in number theory, the ideas of factors and multiples. So we're going to have several definitions here, and let's three different definitions to start off with. We're going to illustrate each of these with a simple example. So the first definition says that the number A is divisible by the number B, or stated another way, B divides A, if the number A divided by B is a whole number. Now these definitions are a little bit hard to understand, so let's illustrate this with a simple example. Let's take the equation 8 divided by 2 equals 4. So 8 divided by 2 is a whole number, and so based off of this we could say the statement that 8 is divisible by the number 2. So this one equation, based off of this, we could say that 8 is divisible by 2. Or another way we could say this is that the number 2 divides the number 8. So from this one equation we can get two statements. 8 is divisible by 2, which is equivalent to the statement that 2 is divisible, or excuse me, that 2 divides 8. Let's look at our second definition. A number B is a factor or divisor of a number A if there is a whole number C such that A equals C times B. Again, this is a little kind of hard to understand, so let's look at a simple example. Let's take the equation 2 times 3 equals 6. And so we could say a couple of statements here. First of all, we could say that 2 is a divisor of 6. Right, 2 is a divisor because 2 times 3 equals 6. Likewise, we could say that 3 is a factor of 6. We could also say another statement, that 2 is a factor of 6. We could also say that 3 is a divisor of the number 6. Okay. So from this one equation we can get four different statements. 2 is a divisor of 6, 3 is a factor, 2 is a factor, 3 is a divisor of 6. Our third definition says that A is a multiple of B if there is a whole number C such that A equals C times B. So again, let's do a real simple example here. Let's take the equation 4 times 3 equals 12. So if we take 4 times a whole number, we get the number 12. And so based off of this, we could say that 12 is a multiple of 4. Let's look at this equation from another perspective. We have that 3 times a whole number equals 12. And so we could say that 12 is a multiple of 3. So one equation, we get two statements here about multiples. Now one very important idea to remember about these definitions and about topics in number theory in general is that these ideas only apply to whole numbers. If we ever have to use a decimal or a fraction to make things work, then we haven't done things correctly. So let me give you an example of what I mean by this. Let's take this equation. 6 times 1/2 equals 3. That is indeed a true statement, and so based off of this we might want to say that, well, if I take 6 times a number I get 3, and so therefore we might be tempted to say that 3 is a multiple of 6. It kind of seems reasonable because we took 6 times some number and we got 3. But the problem is that that number that we had to multiply 6 by was a fraction. and fractions aren't allowed when we talk about factors and ideas in number theory. So this statement here that 3 is a multiple of 6 just isn't correct, because we had to use fractions to make it work. So remember, never use fractions or decimals when we're talking about these ideas of divisors or factors. Now let's do a simple example here dealing with multiples. Let's try to list all the multiples of 6. So by multiple we mean that if we take 6 times a whole number, we're going to get a multiple. So let's just start off with the equation 6 times 1 equals 6. So that means that 6 is a multiple. If we take 6 times 2, we get the number 12. So that means that 12 is a multiple of 6. If we take 6 times 3, we get 18. So 18 is a multiple of 6. And we could keep going on as long as we wanted. 6 times 4 is equal to 24. So there's a multiple of 6. And we could just keep going, increase the second number, and we're going to get a new multiple of 6. So what we see is that we can't list all the multiples. All we can do is list the first few multiples. There's really an infinite number of multiples. Right, our last example, let's look at how we can list the factors of a number. So the number we want to work with here is 24. So by a factor, we mean a whole number that if we take it times another whole number, we get 24. So for instance, let's take this equation. 24 equals 1 times 24. So here we took a whole number 1 times a whole number 24, and that gives us 24. So that means that both 1 and 24 are factors of 24. Let's take another equation. 24 equals 2 times 12. So here we have that whole number 2 times a whole number 12 equals 24. So that means that both 2 and 12 are factors of 24. Well, let's kind of keep doing this. 24 equals 3. So 3 times what number equals 24? Well, 3 times 8. So there we have 3 and 8 are factors. Let's try this. Let's try increasing the 3 by 1 to get 4. 4 times what number equals 24? Well, 4 times 6. So there's 2 more factors, 4 and 6. Let's try this again, 24. Now let's try 5. 5 times a whole number, can we get that to equal 24? Well, that's not going to work. So 5 is not a factor. Let's try 6. Well, 6 times 4 is equal to 24, so there we have 6 and 4 are factors. Well, now let's make an observation here. Notice as we went down this list, these numbers got bigger. As we went down this list here, these numbers got smaller. But now look at what happens here. Well, maybe let's start up here. Notice that the 2 is less than 24, 3 is less than 12, 4 is less than 8. But now we get 6 equals 6. Something kind of changes here. This first number here becomes bigger than the second number, and so if I were to keep going, these numbers here would get bigger, these numbers here would get smaller, but these smaller numbers down here would have to be equal to some of these smaller numbers that we've got up here. So the point here is that we can stop at this point. I don't have to keep trying numbers. Once this first number becomes bigger than the second number, I can stop. And at this point I found all my factors. So all my factors are 1, 2, 3, 4, and then 6. So 4, 6, and now we'll start going up this right hand side. So we got 6, and then 8, and then 12, and then 24. So there we go. There's all my factors of 24. I found them in a quick and efficient way. That's all there is.